What we've got at this point is we've got a rotating solar nebula with a protosun in the middle that is getting larger and hotter because of the material that's falling on it and making it bigger, what we call accretion. What's going to happen with all of this gas and dust that's out here rotating around? Is it all going to be sucked into this protosun? No, we got a different story to tell. What's happening out there is that we've got lots of gas, which is cooler out here away from the protosun. And remember, there are grains of dust mixed in with it. And these interstellar grains are going to be the key to the formation of planets. As you have more matter, more of the gas and dust coming together and meeting, the gas is going to be able to condense onto the dust and form larger particles that we can call grains. This is the same kind of thing that happens to form raindrops up in clouds. You have water vapor coming up off of the earth. It goes up to a higher level where it could cool off. It can meet up with some dust particles, and then it condenses onto the dust particles to form raindrops, and then you see clouds from that. So these gases are out here at the edge of the solar system that's forming, and they are cooler, so they can start to meet up with these dust grains and start to form larger and larger pieces of material that first might start off the size of grains of sand, and then as those grains of sand have enough opportunities to come together and meet and bump together, they're going to start to form larger particles. And it might seem unlikely that in large areas of space you're going to get tiny little particles having the opportunity to meet each other. But remember, it doesn't have to be highly probable in order to happen. It just has to have some chance of happening. And in a long period of time, remember this is an evolutionary type theory, in a long period of time, there will be opportunities for these little pieces to get together and start to form larger pieces. So, the larger pieces start forming maybe the size of grains of rice, and then those have opportunities to collide together, and that forms pieces the size of peas, and they get together and form pieces the size of grapes, and just keep thinking of larger and larger types of foods. That's the way this is going. You're just going to form larger and larger particles. They're going to start to collide together, and they just get bigger when they meet together and add to each other and get larger and larger and larger. And don't forget that these contain dust as well as gas, so it's not necessarily becoming a big gas ball. It's also collecting together these pieces of dust. So these things are eventually going to start to become like large pieces of rock also. So the larger pieces, when they get to be a certain size, are going to be called planetesimals. And we call them that because planetesimals are eventually the larger pieces that come together and become planets. How big are planetesimals? We're going to call it a planetesimal when it's the size of small moons or like asteroids. And so like it's shown in this picture, here you're still going to have little pieces that are forming. They're managing to get together and form larger pieces. These larger pieces actually can start to pull on each other with a little bit of gravity. And gravity could maybe pull them together so they smash together fast. Oops, this one actually broke away some material in that process, but don't worry, that'll be sucked up and collected up by some other rocks, which will then pull together and keep forming larger and larger pieces, until eventually these pieces would get so big that they start to pull in everything around them. They would actually start to clear out a ring of space around the protosun. As they're moving around in orbit, they're going to start to clean things out and form an empty ring going around this protosun. So, if we were actually to look for something like this in space around another star, we would expect to see these dark rings forming where larger sized bodies that are going to become planets would start to form. This is a significant departure from what Descartes was predicting. Descartes thought that you would see rings of material forming around your sun, but he thought that it was these rings that are going to condense down into a planet. Whereas if we were to see rings in this process, we would know that the rings mean planets have already formed and they are making a separation between these rings by cleaning out the material that's in between. Now, over here to this artist's drawing, this artist is going to show another stage of what's going to start to happen into this proto-system when the protostar in the middle starts to get hot enough. While things have been relatively cool, they've been falling in orbit, spiraling on in to hit this protosun and make it hotter and hotter and hotter. But eventually, the protosun is going to get hot enough to make a solar wind. It's like when you make a bonfire and you see all of the hot material rising up above the bonfire, you're looking at stuff that's gotten hot enough to move away from the source of the fire and rise up. The same kind of thing is going to happen with the solar wind. It's going to start to heat up the particles on its surface so much that they have to rise up and move away from the protosun. And that's the reverse of accretion. Now you're going to have particles rising up and moving away from the protosun. That's actually going to create a solar wind, a type of pressure that's going to blow away like the lighter gases. Lighter gases should be easier to blow away first, and so they should be easy to blow away back out to the outer edges of the solar system where they could add to planets that might collect lighter gases like hydrogen and helium. This is how we would expect the large gas giants to form out here and why they would have all of these gases to collect together. But why didn't we get hydrogen and helium in close to the solar system? That's because those gases got mostly blown way out here to the edge. What was harder to blow away was some of the gases that we have in our atmospheres, like carbon dioxide, oxygen, and nitrogen. Those are heavier elements, so they don't blow out as easily. They'd be left behind so that the atmospheres of the terrestrial planets would have heavier elements for their atmospheres. So, after a while, planetesimals are going to become planets. The slower collisions are going to form larger bodies. Any fast collisions might shatter things dramatically and make stuff splatter out, but it would eventually be collected back together, fall back together because of gravity, and form larger bodies. So, we have formed planets at this point out of the planetesimals. The outer planets are going to cool off faster than the ones that are close to the sun, and so those are going to cool off enough that they are easily able to collect up more gas that's out there, so they'll collect larger amounts of gas and become bigger gas planets. Inner planets, they are going to collect lots of rock that didn't get blown away by the solar wind, and they're going to have a little bit of less gas to collect, and so they're going to become more like the terrestrial planets.